Mountains are not formed overnight. They are the result of millions of years of immense geological forces acting deep within the Earth. Today we'll explore how mountains form when tectonic plates collide, step by step, through the science of plate tectonics. Step 1. Plate convergence. The process begins when two lithospheric plates move toward each other due to mantle convection currents. This movement is called plate convergence, and it sets the stage for mountain building. Step 2. Subduction or initial compression. If one plate is denser, it may sink beneath the other in a process called subduction. But when two continental plates meet, neither can sink easily, causing intense compressional stress. Step 3. Closure of an ocean basin. Before continents collide, the oceanic crust between them is gradually consumed by subduction. Marine sediments on the ocean floor accumulate and later become part of the mountain system. Step 4. Continental collision. Eventually, the two continents collide. Because continental crust is light and buoyant, subduction slows or stops, and the crust begins to crumple and deform instead. Step 5. Folding of rocks under extreme pressure. Rock layers bend into large folds called anticlines and synclines. These folds push the crust upward, forming the initial mountain ridges. Step 6. Thrust faulting and nappy formation compression also creates thrust faults, where massive rock slabs slide over one another. Huge sheets of rock, known as nappies, can move tens of kilometers, stacking the crust vertically. Step 7. Crustal thickening and mountain roots. The crust becomes unusually thick, sometimes twice its normal thickness. A deep mountain root forms beneath the surface, supporting the towering peaks above. Step 8. Isostatic uplift. As the crust thickens, it rises to maintain gravitational balance, a process called isostasy. This causes mountains to continue rising, even after plate collision slows. Step 9. Metamorphism and magma formation. Deep inside the mountain belt, high temperature and pressure transform rocks through regional metamorphism. In some areas, partial melting creates granitic magma, which intrudes into the crust. Step 10. Erosion and continuous uplift. Wind, water, and ice slowly erode the mountain surface. But as material is removed, the crust rises again, exposing deep metamorphic rocks and reshaping the mountains over time. This is how massive mountain ranges like the Himalayas are formed, through collision, compression, uplift, and erosion over millions of years. If you enjoyed learning the science behind mountains, like the video, share it, and subscribe for more Earth science content.